Hi, I'm Christopher Millard. I'm of counsel with Bristows and Professor of Privacy and Information Law at Queen Mary, University of London. I'd like to talk to you about cloud computing. What is cloud computing? Why is it such a hot topic? Well, put at its most simple, cloud computing is online, scalable IT resources on demand delivered by a network, usually the internet. Now, there's an awful lot in that, and I will unpack it a little bit. But essentially, it's about computing as a utility. So instead of buying your own hardware, installing the software, having people maintain it for you, and updating it regularly, you buy computing power, or compute as it's called, and you buy storage as a service, and it's delivered to you typically via the internet. And this has a number of advantages, including the fact that you can scale it up or scale it down pretty much real time. So instead of spending years planning to build a new data center, if you're a large corporate or a government agency, or even spending weeks or months procuring some new IT hardware in a typical company, you can actually get almost, well, for practical purposes, unlimited computing and storage resources available on demand any time of the day or night, any day of the year. What I'm going to talk about in a moment is the typical types of cloud computing you're likely to hear about and who the main actors or the main players are in the cloud computing scene. But just one more general introductory comment. Some people are describing cloud computing as potentially a very disruptive development and an innovation potentially as important as electricity being delivered via the grid. And I'll just talk about that for a moment. If you remember, those of you who've read the history, about 100 years ago, when a chap called Thomas Edison started trying to sell people electricity from his new fangled power grid, apparently what people said to him was, there's no way we could trust something as essential as our electricity supply to an outside provider. We have our own generators in the basement, and we have our own fuel, and we have our own people keeping it going all the time. So it's far too important for us to buy your electricity. And actually, Thomas Edison had a great difficulty getting people to buy electricity for quite a while. In the end, it became so much cheaper and so much more reliable to buy his service via the grid than generating it yourself, that almost everybody in the world now gets their electricity from an external supplier. Some people are saying cloud computing could end up being as radical a development as that, but for computer processing and for computer storage. So why is it so hot right now? We've talked about technology innovation, but there are some real important commercial drivers here too. The fact that you can scale up or scale down your computing requirements almost in real time, as I said earlier, is very important for startup businesses. It's very important for large businesses and governments that have big differences between the peaks and troughs of their processing and storage requirements. So let's say, for example, you're an online retailer, and a couple of times a year you have a huge surge in orders that you have to process and fulfill. Instead of making sure you have a big enough data center to manage the extreme peaks of demand, you can just scale up or scale down whenever you need it, your computing, processing and storage. There are some other benefits, though, that are particularly important at the moment and have probably driven the very rapid expansion of cloud computing in the past few years. One of these is that in terms of efficiency, sharing a large data center or several data centers with lots of other customers, and I'll get on in a moment to how that works in practice, but sharing IT resources can produce enormous efficiencies compared to building and maintaining and running your own IT infrastructure. That's because, for one thing, there are economies of scale if you build a very large data center, but more importantly, it's possible to use the resources much more efficiently. So whereas a typical customer with its own equipment and its own IT resources generally may only use a fraction of its capacity on an averaged out basis over 24 hours a day, 7 days a week, 365 days a year, a cloud computing provider can make available enormous computing resources to very large numbers of customers and achieve much higher utilization rates and, as a result, much lower costs, which can be passed on to the customer. Another reason cloud is very big at the moment in terms of the news and in terms of the growth of the market is that there's a big push to make government services more efficient. And although some governments around the world are very reluctant to put data about their citizens into a cloud computing environment, the cost benefits again and the efficiency and productivity gains are becoming so compelling that gradually governments around the world are starting to use cloud computing. And one final thing about why it's so hot at the moment is that there's been an explosion recently, which is likely to continue, of the deployment of mobile platforms and mobile apps. And we're just at the beginning of a further disruptive development, which people are calling big data, which includes very large-scale data analytics, where enormous data sets can be analyzed in a way that was not previously possible. And one of the key enabling technologies for that is cloud computing. In terms of numbers, how big the market is, there's lots of scope for speculation there, and there are plenty of numbers out there. But Forrester Research, for example, has predicted that the market for cloud computing services globally will grow to about 250 billion by 2020. But even bigger numbers are out there. The European Commission, for example, has predicted a cumulative impact just within the European Union of 940 billion euros and 3.8 million jobs between 2015 and 2020. Now, whether those numbers turn out to be right is not the point. The point is this is a big market and it's a significant commercial development. Now, the main types of cloud service, what I want to talk about next. And this is inevitably a simplification, and I apologize to those of you who are technically adept in this field and could go into a lot more detail. But for the purposes of most people, when they're trying to understand cloud computing, for their own businesses or for their own deployment purposes, it's usually simplified down to three levels or three layers. The bottom layer is called Infrastructure as a Service. IaaS is how it's normally written. And this means the core infrastructure in terms of hardware, the physical devices, the power supplies, the actual physical premises and so on that can be used for running software and running services. So infrastructure is the bottom layer. The next layer up is usually called PaaS, Platform as a Service. And this is a bit more complex and sophisticated than infrastructure as a service, because typically PaaS is a complete computing environment and will normally involve an operating system and various other software tools so that you can run applications on it. And the highest layer, if you want to look at it that way, is SaaS, or Software as a Service. And this is about fully configured, fully functional software applications of the type that in the past you might have run on your own machines in your own premises, but now you can just run them remotely via a cloud computing service. I'll just give you a couple of examples of each. So taking infrastructure as a service first, examples are Rackspace, which is a very large cloud infrastructure provider, Amazon, which is well known for its retailing services, but actually is one of the world's largest and most sophisticated cloud computing providers as well. And it offers infrastructure services that are used by many other cloud service providers. In terms of the platform level, that middle level I described, examples include Microsoft Windows Azure, which is Microsoft Windows, but instead of running on your own device locally, it's running in the cloud. And Google App Engine is another example at that level. At the top level, the fully configured, delivered application software level, examples include Salesforce.com, which can run your HR or CRM applications. Again, delivered direct to your desktop, your laptop, your smartphone, your tablet, whatever device you want to use to access that service. A service that's used by many consumers, but also by some businesses that's well known, is Dropbox. And there's an interesting example of how layering works in practice. A lot of people think if they upload their files to Dropbox, they are handing over their data to Dropbox for safekeeping. Actually, Dropbox doesn't have the servers itself to store your data. It uses Amazon Web Services. And that's not clear to, I think, many users of that service, and indeed most other cloud services. Other examples of fully configured software as a service include Microsoft Office 365 and Google Apps, including Gmail. Now, I want you to have a look at this picture for a moment, because I think, as is often the case, it can tell 1,000 words. This, again, is a simplification, inevitably. But if you look on the left-hand side of the picture, you'll see the brown building, which is depicting the traditional on-premises internal processing operations and storage of data. And on the right-hand side, you see a cloud which has a number of bubbles in it, which are really clouds. So you could call this a cloud of clouds. And if you want to imagine, those different bubbles are filled in with the names of major cloud service providers, such as Amazon and Microsoft and IBM and Google and HP and Apple and so on. Now, the traditional model, as I said earlier, is a bit like generating your own electricity. You do everything in-house, and it's very costly, it's very time-consuming. It may turn out actually to be quite risky, and I'll get to that in a moment. The right-hand side, which we call public cloud, these are shared cloud environments, or the technical jargon is they are multi-tenancy cloud environments. They have lots of different tenants using the infrastructure. That is the kind of hugely scalable environment that I was describing at the beginning, where literally millions of different customers can be using the same cloud infrastructure service at the same time. An interesting space that I want you to look at now is the rectangle, which is headed hybrid. Hybrid cloud is actually the fastest growing area of cloud computing at the moment. And the hybrid cloud is seen by many people as giving you the best of both worlds, because you can carry on using your private internal resources and expertise, and you can also use public scalable cloud whenever you need it. In fact, that's called cloud bursting, when you burst out from your internal processes to the almost unlimited capacity out there in public clouds. And it's particularly attractive at the moment to customers that are concerned about confidentiality and privacy and various other regulatory constraints that mean they are not quite ready yet to just move everything to the public cloud and do away with their own IT resources. And I think this hybrid cloud arrangement is going to continue to grow for some years to come. It may be that in time people get more comfortable with the public cloud and move more and more into that, but at the moment that's a significant growth area. Now, there's just one other type of deployment model that's not in this picture, which is also growing quite fast at the moment, and that's called a community cloud. And it's kind of a bit like a hybrid cloud, but for the members of a wider community that have similar concerns. And areas where that may prove to be very significant, again, include highly regulated sectors such as financial services and healthcare and so on, where many of the customers of cloud services or potential customers in those areas share common concerns about security and regulation and privacy and so on. And they can then have delivered to them a more customized, specialized cloud platform and service environment, perhaps with extra security. So I think we will continue to see growth across the board in cloud computing, but especially interesting developments happening in hybrid and community clouds. Now, there's a lot more we could say about what cloud computing is and how it works. Just one last bit of technical jargon that you might encounter, and that is virtualization, and related to that, virtual machines. One of the key technical developments that has made cloud computing possible is the conceptual separation of the physical infrastructure from the virtual software and data processing environment. And so instead of needing, going back to where I started, instead of needing your own machine in your own building to do everything, you can now use machines that are remote. They could potentially be multiple machines in multiple locations. And those machines can be shared by many different customers at the same time, because on those machines, virtual machines or virtual machine images are run and stored, which can be used by lots of different customers. And that, again, is at the heart of the efficiency savings from cloud computing. Thanks very much.